Welcome to the deep dive. Okay, let's get right into it today. Triglycerides.
Yeah, they pop up everywhere, don't they? Blood tests, health articles.
Exactly. And there's, well, a fair bit of confusion, I think, especially about dietary fat and how it connects.
For sure. That's why we've gathered some really solid info.
We want to cut through that noise. We've got some material here that clarifies what triglycerides really are and, crucially, how you can manage them.
Right. There's this common idea that just eating fat equals high triglycerides.
Which isn't the full picture at all.
Not really, no. So our mission today is simple. Understand triglycerides. What are they? When are they actually a problem? And what works to keep levels healthy based on what we found?
Okay, let's start right at the beginning then.
Yeah.
What are triglycerides, basically?
Think of them as energy, stored energy. You get them from food, specifically fats.
Okay.
Or, and this is key, your body can actually build them itself.
Build them. How does
Yeah.
that work?
Well, when you eat fats, your body breaks them down into fatty acids. Then it absorbs those and can, reassemble them into triglycerides for storage or transport.
Got it. So when we see that number on a blood test, what's it telling us, really?
That's a great question. It's kind of an indicator. It tells you about the main fuel source your body is tapping into at that moment.
Fuel source, meaning fat or carbs.
Exactly. Since triglycerides are fat, lower levels, well, they often mean your body is actively burning fat for energy. It's using them up.
Okay, so lower levels suggest fat burning. Makes sense.
Yeah.
What about the flip side? High levels.
High levels often point towards a diet that's higher in carbohydrates.
Ah, carbs, not necessarily fat.
Right. Here's the important part. If you eat more carbs, especially the sugary, quick-burning kind, then you need right away.
Like bread, pasta, sugary drinks.
Yeah, stuff like that. That extra energy doesn't just disappear. Your body converts it into fatty acids, then packages those up as triglycerides. For storage,
So high triglycerides can actually be a sign of eating too many carbs.
often, yes, it's a marker of that excess sugar getting turned into fat. It really challenges that old, fat makes you fat gives you high triglycerides idea.
Wow, okay, that's a big shift in thinking for a lot of people, I bet.
It is.
So this understanding is pretty critical then if you're looking at weight loss
Yeah.
or fat burning
Hmm.
or even those diets like keto or paleo that are higher in fat.
Oh, absolutely fundamental. You need to know how triglycerides function in those contexts. I mean,
Mhm.
think about it from an evolutionary standpoint.
Okay.
Our bodies are designed to store energy. Quick energy from sugars, yes, but also longer-term reserves as fat as triglycerides. It was survival, when food wasn't always available.
Storing up for lean time.
Exactly. But now, food's everywhere for many of us.
Mm.
So constantly adding to those stores, especially from carbs, leads to that buildup, that high triglyceride number.
Okay. Now, you mentioned the body choosing between sugar and fat. What controls that switch?
The main player there is insulin. Most people know it for blood sugar control.
Right.
But it's also the hormone that basically tells your body, burn sugar now, or tap into fat stores.
And how does that work with triglycerides?
Generally, lower insulin levels signal the body to start using more fat, more triglycerides.
So less insulin, more fat burning.
You got it. And this is huge for people struggling with weight loss, even if they're dieting and exercising.
How so?
Well, if someone has insulin resistance, their body isn't responding properly to insulin's signals, it becomes really hard for them to access and burn that stored fat. Their body sort of defaults to wanting sugar.
That sounds like a major roadblock for weight loss.
It really can be. Addressing insulin resistance is often key.
Okay. Now, the source material brought up something interesting about what happens when someone starts losing weight, especially if they have a lot to lose.
Yes. That's important context. You might actually see a temporary increase in triglycerides when someone starts losing significant weight.
An increase. Why? That seems counterintuitive.
Well, think about it. The body is breaking down stored fat, right? That fat gets released into the bloodstream as triglycerides to be transported and used for energy.
Ah, so more fat is just sort of in transit.
Exactly. It's being mobilized. So you might see a temporary bump in the blood test numbers, but, and this is the important part, if the weight loss continues and the diet is improved, those levels should come down nicely as the body gets better at using that released fat.
Okay, so a short-term rise isn't necessarily bad news. Good to know.
Don't panic if you see it initially.
Right. Now, let's address that apparent paradox. Low-carb, high-fat diets. You'd think eating more fat would send triglycerides soaring. what actually happens.
It does seem backwards, doesn't it? But what happens is fascinating. When you really cut down the carbs, your body has to switch its main fuel. It becomes much, much more efficient at burning fat.
Because that's what's primarily available.
Precisely. So those triglycerides floating around in the blood, they get snapped up and used for energy much more rapidly. The body adapts.
So reducing carbs often leads to lower triglycerides, even with more fat.
For many people, yes, it's often the most effective way. The body just gets better at using fat.
How does the body move these triglycerides around? The source mentioned transport.
Yeah, good point. Triglycerides are fats, so they don't mix well with blood, which is mostly water. They need carriers.
Like little boats.
Kind of. They're called lipoproteins. You've probably heard of LDL and HDL for cholesterol.
Sure.
Well, for triglycerides, the main carriers are things called chylomicrons, which carry dietary fat, and VLDL, very low-density lipoprotein, which carries triglycerides made by the liver.
Okay, so VLDL carries triglycerides. Got it.
And to actually get the energy out of those triglycerides carried by VLDL or chylomicrons, you need an enzyme. It's called lipase.
Lipase unlocks the fat.
That's a perfect way to put it. It releases the fatty acids so your cells can use them. And here's the cool part. Lipase activity tends to go up on a healthy, high-fat diet. And it tends to go down on a high-carb diet. The body adapts its tools to the fuel it's getting.
That makes complete sense. You build the tools you need most.
Exactly. And we see this in studies. People who are overweight with high triglycerides, they switch to a healthy, high-fat, low-carb approach.
Yeah.
Their triglyceride levels often drop dramatically, like cut in half, sometimes within weeks, even though they might be eating, say, triple the amount of fat they were before.
Wow, because their body's burning it so efficiently.
Precisely. The efficiency ramps up.
Okay, that's a really crucial point. So what are we aiming for? What's considered a normal or good triglyceride level on a lab report?
Generally, the target most labs use is less than 100 milligrams per deciliter, or mgdl.
Under 100.
Yeah. But what you see in reality often falls into two camps. People with, let's say, less optimal diets, maybe some liver sluggishness, high carb intake, especially if they're overweight. Their numbers can be much, much higher, 200, 300, even more.
Right.
On the other hand, people doing things like regular intermittent fasting or following well-formulated ketogenic diets, they often have significantly lower levels, maybe down in the 50s or 60s.
So normal is really relative to lifestyle.
Very much so. The number needs context.
Let's dig into the reasons why someone might have high levels. We touched on carbs.
That's the big one. Excess carbohydrate intake, especially those high glycemic carbs that spike your blood sugar quickly.
White bread, sugary cereals, potatoes.
Things like that, yeah. When you eat a lot of them regularly, it can overwhelm the liver's ability to process the sugar efficiently. It has to do something with the excess.
And that something is making triglycerides.
Exactly. It converts the excess sugar to fatty acids, packages them as triglycerides, and sends them out into the blood. Very common cause, especially linked with being overweight.
Okay. But what about people trying a high-fat diet, like keto, who still see high triglycerides? That seems odd given what we just discussed.
It does, but it usually comes down to, well, how strictly they're actually doing the diet.
Meaning?
Keto, for example, needs very specific macronutrient ratios to work properly, usually something like 70% fat, maybe 25% protein, and crucially, under 5% carbs.
Very low carb.
Extremely low. If someone is aiming for keto, but they're consistently eating, say, 10 or 15% carbs, they're not getting enough carbs for normal energy, but they're also not low enough to force that full switch to fat burning.
Kind of stuck in the middle.
Exactly. They're not getting the fat burning benefits, and they're still getting more carbs than ideal for that state. So the triglycerides can actually accumulate. You need to be quite precise, especially initially.
Right, you have to commit to the process for it to work metabolically.
What about genetics? People often say high triglycerides or cholesterol run in the family.
That's a really common thing to hear, and yeah, families often share results. But is it truly genetics, or is it shared habits?
The nature versus nurture question.
Kind of. In most cases, it seems to be more about the shared lifestyle, the foods everyone eats, activity levels,
Yeah.
That leads to similar blood work across family members.
So learned behaviors more than pure DNA.
Often, yes. That said, there are genuine genetic factors that can influence fat metabolism. And there's testing available now in nutrigenomics or nutrigenetics. What does that tell you?
It can identify specific gene variations that might make you process fats differently, affecting triglyceride or cholesterol levels. That info could help personalize diet advice. Maybe a super high-fat diet isn't ideal for your specific genes.
Interesting. So genetics can play a role, but lifestyle is usually a bigger piece.
Generally, yes, though testing can offer clues for some individuals.
Okay, the last reason mentioned for high levels was poor hepatic metabolism. What's that about?
Hepatic just means related to the liver, so poor liver function.
Like fatty liver disease.
Exactly. Things like non-alcoholic fatty liver disease or problems with the gallbladder, which helps digest fats, or even having had your gallbladder removed. These can all impair how well your body processes dietary fats.
And that leads to higher triglycerides.
It can, yeah. If fat metabolism isn't efficient, you might see triglycerides and maybe LDL cholesterol creep up. So supporting overall liver health becomes important.
Right. Okay, so that covers the main causes. Let's shift to solutions. What are some natural ways to bring those numbers down?
Good news is there are quite a few effective strategies. First off, surprisingly perhaps, is increasing healthy fats, specifically monounsaturated fat.
Like olive oil, avocados.
Yes, those are prime examples. Nuts, too.
Yeah.
Even just switching your cooking oil to olive oil can make a difference for some people. It seems paradoxical, eating fat to lower fat in the blood, but the type of fat matters.
Right. More healthy monounsaturated fats. What else?
Omega-3 fatty acids. These are really powerful.
From fish.
Fatty fish are excellent sources. Think sardines, anchovies, mackerel, salmon, cod. They're rich in the EPA and DHA types of omega-3s. Plus, you get vitamin D. Interestingly, populations who eat a lot of these fish often show greater longevity.
Yeah, other sources.
Pasture-raised meats tend to have a better omega-3 profile than conventionally raised meats, and of course there's supplementation.
Fish oil capsules and things like that.
Exactly. The source suggested that while EPA and DHA are often highlighted, pretty much any form of omega-3 can help lower triglycerides, though the plant-based ones might offer slightly different cardiovascular benefits overall.
Got it. So increase healthy fats, increase omega-3s. What about carbs? We know excess is bad.
So the strategy is to reduce the overall glycemic load of your diet. Focus on carbs that digest slowly.
Vegetables.
Most vegetables are great. They release their sugar slowly, avoiding those big spikes. You do need to be a little mindful with fruit, though.
Why fruit? It's healthy, right?
It is, but it contains fructose. And fructose is metabolized mainly by the liver, and it's somewhat more easily converted into triglycerides compared to glucose. So moderation with fruit might be wise if triglycerides are high.
Makes sense. Less sugar impact overall. How about exercise?
Definitely helpful. The information we looked at pointed towards sustained, moderately intense exercise as being particularly good.
Like jogging, cycling.
Yeah, something where you're working at maybe 75–80% of your maximum effort, sustained for, say, 10 to 15 minutes.
Okay.
And there's an extra benefit if you can exercise in a fasted state.
Fasted, like before breakfast.
Yeah, after maybe 10 or 12 hours without food, doing that moderate intensity exercise then seems to really ramp up fat burning and help lower triglycerides more effectively.
Interesting. So timing matters too. Any other lifestyle factors?
Alcohol is a big one. Reducing intake can make a noticeable difference.
How much of an impact?
Well, the source mentioned that even a moderate amount, they cited about 38 milliliters, which isn't very much, like a large shot,
Yeah.
could potentially increase triglycerides by up to 50%.
Wow, 50%. Why such a big effect?
Because the liver prioritizes metabolizing alcohol above almost everything else. So when it's busy dealing with alcohol, processing fats and sugars takes a back seat, which can lead to more triglycerides being made.
Okay, so cutting back on alcohol seems like a key step for many.
Definitely worth considering.
Now, one food always comes up in these discussions.
Right.
Eggs. What's the deal with eggs, cholesterol, and triglycerides?
Ah, yes, the egg debate. It's often linked to cholesterol, and people sometimes lump triglycerides in there. But the key factor seems to be the quality of the egg.
Meaning where it comes from.
Exactly. It depends heavily on what the hen ate. Pasture-raised hens, hens-fed organic diets, especially those supplemented with omega-3 sources like flaxseed. The eggs they produce seem to have much less impact on blood lipids.
Compared to standard supermarket eggs.
Right. Studies show different effects. Conventional eggs might raise lipids slightly in some people, whereas these higher quality omega-3 enriched eggs often show minimal impact.
So the advice isn't necessarily no eggs, but maybe better eggs.
That seems to be the takeaway, yes. Focus on quality.
Okay, so bringing this all together, what's the final word on managing triglycerides?
The really positive message is that it's generally very achievable. Through these kinds of dietary changes, managing carbs, choosing healthy fats, getting omega-3s, and lifestyle adjustments like exercise and moderating alcohol, most people can significantly improve their levels.
And see results fairly quickly.
Often, yes, and it's so important long term. Managing cholesterol and triglycerides is fundamental for cardiovascular health, preventing heart disease, which is still, a massive global health issue.
Absolutely. Were there any supplements mentioned besides omega-3s as potentially helpful?
Yeah, coenzyme Q10 or CoQ10 was mentioned briefly. It's involved in energy production and has antioxidant properties.
So omega-3s and CoQ10 might offer extra support.
They could, yeah. But honestly, the foundation is those diet and lifestyle changes. Supplements are likely secondary for most people who make those core changes.
So the big takeaway seems to be really understanding that link between carbs, fat burning, and triglyceride levels. That connection is crucial.
It really is. And that leads to a thought for everyone listening.
Yeah.
Think about your own diet, your energy levels through the day. How flexible do you think your metabolism is? Can your body easily switch between burning carbs and burning fat? Exploring that idea, maybe based on some of what we talked about today, that could be a really powerful next step for your health journey.